Area factor and perimeter factor. Hello friends, the topic of this presentation is area factor and perimeter factor. We'll concentrate on regular polygons. Area factors and perimeter factors are numbers for regular polygons like an equilateral triangle, square, pentagon, hexagon, heptagon, octagon, nonagon, and decagon, etc. These factors work for regular polygons. We usually find area and perimeter for different two-dimensional objects. But one thing we must know that if two figures are identical, then their area and perimeter can be found by changing one factor in the formula of other. For example, we can find the center of the figure and find the factor by which the figure has been zoomed. Then we can use the factor to find the area and perimeter of the symmetrical figure. Although the area factor can be found for symmetrical figures, but we can concentrate more on regular polygons. Area factor is a constant for a figure with fixed number of sides, mainly regular polygons, which when multiplied to the square of the circumradius gives the area of the polygon. We will denote it by AF. Similarly, the area factor and perimeter factors give the perimeter of polygons. Perimeter factor is a constant, which when multiplied to the circumradius gives the perimeter of the regular polygon. We will denote it by PF. Area factor AFN. We will denote the area factor of for n sides of a polygon by AFN. For equilateral triangle it is AF3, for a square it is AF4, so on. AFN is equal to n by 2 sine 360 degrees by n. Perimeter factor PFN. We'll denote the perimeter factor for n sides of a polygon by PFN. For equilateral triangle it is PF3, for a square it is PF4, so on. PFN is equal to 2n sine 360 degrees by 2n. Area. Area of regular polygons with n sides. AN. And circumradius R is R square n sine 360 degree by n. Perimeter. Perimeter of a regular polygon with n sides Pn and circumradius R is 2n r sine 360 degree by 2n. Area factor for equilateral triangle AF3. As we know that an equilateral triangle has three sides, so we substitute the value of n in the formula n sine 360 degrees by n and find the area factor. The area factor for equilateral triangles comes out to be 3 root 3 by 4. Area factor for a square AF4. As we know that a square has 4 sides, we substitute 4 for n and get the area factor as 2. Perimeter factor for equilateral triangle PF3. We substitute 3 for n and get the perimeter factor as 3 root 3. Perimeter factor for square PF4. We substitute 4 for n and get the perimeter factor as 8 by root 2. Equilateral triangle. Area for equilateral triangle with circumradius 4 units each. See the calculation. It is equal to 12 root 3. Perimeter for equilateral triangle with circumradius 4 units each. See the calculation. It is 12 root 3. Square. Area for square with circumradius 3 units each. Look at the calculation. It is 18. Perimeter for square with circumradius 4 units each, circumradius 3 units each. Look at the calculation. It is 12 root 2. Thank you for watching the video. Have a good day.